Hi everyone, welcome to Electronics with Professor Mughal. We have a request today. One of my follower, Ibrahim, he sent me a request. He wanted to learn about power transfer. So maximum power transfer. In order to understand that, you have to have a knowledge of a load. So what is a load? A load could be an element, basically anything that is connected as an output or part of your electric network, which you consider as an output. So a fan or a motor or a LED, it could be speaker or anything of that nature. The amount of maximum power delivered to that load depends upon the internal resistance of that particular network. And today we are going to do a small experiment where I'm going to show you, I'm going to start off with a theory a little bit about the maximum power transfer, and then show you the maximum power delivered to our load, which is very a critical parameter, because if you don't provide enough power to your load, it's probably not going to work at its full efficiency. So we will learn today from this small experiment in the next few minutes that the maximum power delivered to your load is actually dependent upon the value of the internal resistor. And if the two values, with the resistance of your load and the internal resistance of the network, matches, that is when you get the maximum power. If the two resistance are same, that is when you get the maximum power delivered to your load. So without wasting much time, let's get rolling. We're going to create this circuit in Tinkercad and then do a simulation. And on top of it, we're also going to import our data into the Excel sheet, and we'll see if the maximum power delivered is at what resistance. Okay, alright, let's get rolling. But before you watch the rest of the video, go ahead, take your time, subscribe to the channel right now. Alrighty, thank you. Okay, so let's go through a little bit of theory over here about maximum power transfer. A load is usually referred to an element connected at the output that consumes power. Like I said, this could be anything: fan, motor, speaker, or things of that nature. If we connect a load resistor, to a simple circuit with only a voltage source and an internal resistor, just like you see over here, there's a source, there's an internal resistor, and in series you have the load. This is a schematic symbol for potentiometer. And we are going to vary the load, vary the resistance, and then calculate the power across this load. That's what this experiment is about. Then this load resistor will have maximum power delivered when its value equals to the internal series resistor. If the value is equal, the load resistor value is equal to that of the internal resistor value, then it receives the maximum power delivered. As shown in the circuit below, when the load resistor is same to the series resistor, the power delivered to the load resistor can be calculated in the following steps. So we know power, how to calculate power. Just simply apply Ohm's law. PL equals to V square over R. V square over R. That's the formula that we are going to implement. But in order for us to get started, we're gonna have to draw this circuit. Not draw, but basically build this circuit. So what I did, I just went ahead and created this circuit already. Just wanted to save time. I have this circuit ready already. Notice this is my VS wire. It's the positive terminal of this rail right here, the red one. The positive terminal of the power supply is connected to the resistor through this green wire right here. And this resistor is connected in series with terminal 1 of the potentiometer. Notice that potentiometer has 3 pins, right? Terminal 1, this is your wiper, and this is terminal 2. I'm going to connect the wiper to the ground using this green wire right here, okay? And that's basically my circuit complete. I also have the power supply. Of course, I'm going to need a power supply. I'm going to set the voltage to 8 volts. I have one multimeter here. This multimeter is hooked up to potentiometer. Basically, it's hooked up to terminal 1 of the potentiometer and the wiper of the potentiometer. So it is going to tell us what is the value of the potentiometer. I've gone with the potentiometer value of 10 kilo ohms, and I've gone with the resistor value of 1 kilo ohms. I got a couple of more multimeters. This multimeter is going to tell us the voltage across the resistor, and hence you got this yellow connected to terminal 1 of the resistor and the black one connected to the terminal 2 of the resistor. And finally, this multimeter we are going to use that to determine the voltage across the load. Remember, potentiometer is acting as a load. We are going to vary the resistance and calculate the voltage at different resistances. Okay, so the voltage, similarly, in order to calculate the voltage, to measure the voltage, we're gonna have this positive terminal of the multimeter connected to the terminal 1 and the negative terminal of the multimeter connected to the wiper. Okay, so I'm not going to show you like how to create this circuit, like build the circuit in Tinkercad, because we have done a lot of tutorials on Tinkercad already, and I'll leave the link in the description if you're really naive to the Tinkercad. But this is how the circuit will look like. What I have done, I have created an Excel sheet. I'm going to vary the resistance of the potentiometer starting from 200 with an increment of 200 ohm every time I take new reading, and go up to 2000 ohms. We are going to measure the voltage using multimeter and then calculate the power. So calculate power is just simply, square of this and then dividing it by the resistance R. So it's a very simple formula right here, which I've already applied. V square, remember V square over R, V square V2 times B2 divided by A2. And if I can just, select this cell and drag it all the way to the bottom, that formula will be adjusted on every cell, right? Notice over here, these values changing over here as I move from one cell to another, right? Okay, already. Let's start with 200 ohm. I am going to go to Tinkercad and I'm going to start simulation. I'm going to turn my power supply off for to adjust the value of the resistance. Right now it's 600 ohm, right? I am going to move it down to 200 ohm and then switch it back to voltage mode. Turn the voltage power supply on. Looks like I'm getting 1.3 volt. Notice that these two voltages and these two voltmeters are going to be same because they are hooked up to the same terminal of the potentiometer. However, this multimeter here is going to tell us measure the voltage across this resistor. And if we add these two values, 6.66 plus 1.34, we basically get 8 volts. And that's what we were expecting because power supply given is 8 volts. So the two voltage drop across this 1 kilo ohm resistor is more versus this over, because this potentiometer is set to 200. So I'm going to go back to my Excel sheet and I'll say this is 1.34 volts. Remember, this measured VRL measured is in volts, right? And the power is going to be in watts. So we have this number right here. Let's move on to, I'm going to turn the power supply off here again, and I'm going to change the resistance to 400 now. 400. Okay, let's go back to the voltage mode. Turn the power supply on. Take the readings. 2.29 volts this time. 2.29 volts this time. Let's do it again for 600 ohm. Let's change the resistance to 600. Now we move it back to the voltage mode, turn the power supply on, and now this time 3 volts. So 3 volts here. I'm going to do it for the rest of the values as well. So now that we have measured the voltage across the load for all the values of resistance in this table, and we have the power as well in watt, maybe I want to convert this power into milliwatt. So I get a number which is going to be in few hundreds that way. So milliwatt, and all I need to do is to multiply these values by 1000, right? Multiply these values by 1000, and I'm just going to drag this formula all the way to the bottom for all these combinations. Okay, and now I'm going to select the two columns. Resistance, I want to keep that on the x-axis, and on the y-axis I want to keep my power. Let's go ahead and create a plot. This looks good right here. I'm going to hit OK, and here is our power plot right here. If I make it big like this, notice here around this time we see the maximum power, which is 16 milliwatt, and it is around 1000 ohm resistor. Let's go back to Tinkercad. What is the value of the internal resistor? It is 1 kilo ohm, which is 1000 ohms. So the maximum power delivered to the load is when the resistance here reaches that of the internal resistor. If I set this to 1 kilo ohm here, and I measure the voltage now, this is going to give me 4 volts, and this is the max. This is where I get maximum power, 16 milliwatt. So remember, your maximum power delivered to the load is going to be whatever the value of the internal resistor is. Okay, and so say if you have something like this, your circuit, and you have your potentiometer or the load resistor here, you're going to have to find the equivalent resistance of this part of the network. So these two are in parallel and they combine in series with this resistance, and you take a sum of these two resistance, then whatever you get is going to be internal resistance of this network. And if that value of the resistance equals that of the load resistance, that is when you supply maximum power transferred to the load resistor. So very simple phenomena, but very important in electronics. I hope you enjoyed this lecture, and till then, next time I'll see you. Bye.